Hello guys, welcome back. Today we are going to see the left out aquifer problems in GATE, the questions which are asked already in GATE examination. So it might be useful for you to approach the exams like GATE. So kindly go through this problem for your good to get good marks. First question: a fully penetrating tube well in a 30-meter deep confined aquifer with a hydraulic conductivity of 4 into 10 to the power of minus 4 meter per second and has a discharge of 50 liter per second. The drawdown and radius of influence are 5 meter and 250 meter diameter of the tube well. They are requested to find the diameter of the tube well in mm. So first write the given data. Hydraulic conductivity K is equal to 4 into 10 to the power of minus 4 meter per second and discharge Q is equal to 50 liter per second. And the drawdown S is equal to 5 meter and radius of influence R is equal to 250 meter, and they had given the thickness 30 meter, depth D. So we want to find the diameter of the tube well. So write down the formula. As you all know that Q is equal to 2 pi kb S divided by ln of R by R1. So 2 into pi into K they had given 4 into 10 to the power of minus 4. Thickness they had given 30 into 5. Here the drawdown is 5 meter. So 5 divided by ln of radius of influence 250 divided by R1. So Q they had given 50 liter per second. You can convert this into meter cube per second. So 50 into 10 to the power of minus 3 is equal to 2 into pi into 4 into 10 to the power of minus 4 into 30 into 5 divided by ln of 250 by R1. So when you solve this equation, ln of 250 divided by R1 is equal to 0.3769 divided by 50 into 10 to the power of minus 3. So again you solve this, you can get 7.539 ln of 250 divided by R1. So you want to cut down this ln, so taking E on both sides. So 250 divided by R1 is equal to E to the power of 7.3539. So E to the power of 7.539 value 1879.94 R1 250. So R1 is equal to 250 divided by 1879.94. So you can get the R value. R1 is equal to 0.13298. In question they are requested to find the diameter of the tube well. So you want to find the diameter. So radius you had given. So diameter D is equal to 2 into radius. 2 into 0.13298. Diameter D is equal to 0.26596 meter. In question they are requested to find in M. So diameter D is equal to 265.965 mm is the correct answer. So note it down. So you want to write the given data correctly to get the correct answer, so that only you know how to proceed the formula in the forthcoming questions. So next question: an unconfined aquifer extends over an area of 1 km square and has hydraulic conductivity, total porosity and specific retention of 20 meter per day, 30% and 10% respectively. After pumping some groundwater from this aquifer, the water table dropped to a depth of 20 meter from the ground level. if the water table was initially 14.5 meter below the ground level, the change in the groundwater storage in million cubic meters would be, first write the given data. K is equal to 20 meter per day. N they had given 30 percentage, and the specific retention they had given 10 percentage. S1 they had given 20 meter and S2 14.5 meter. Area they had given us 1 kilometer square. So total porosity N is equal to specific yield plus specific retention. So you want to find the specific yield is equal to 0.3 minus 0.1. Specific yield is equal to 0.2. So the formula becomes change in groundwater surface is equal to area into drop in water table into specific yield SY. So area they had given us 1 kilometer square. So we want to find the answer in cubic meters. So this converted into kilometers square into meter square. So 1 into 1000 into 1000 into drop in water table, as you all know that 20 minus 14.5 into specific yield, you find it out 0.2. When you solve this, you can get the value changing groundwater table in million cubic meters, 11 lakh million cubic meters. So next question. A 200 mm fully penetrates a confined aquifer after a long period of pumping at a rate of 1400 liter per minute. The drawdown in the observation wells are 25 meter and 40 meter from the pumping well are found to be 2.6 meter and 1.9 meter respectively. The transmissivity of the aquifer in meter square per day. Here they request to find out the transmissivity T. So what are the things they had given? So diameter D is equal to 200 mm. Q is equal to 1400 liter per minute. Liter per minute you want to convert into meter cube per second. Then R1 value is equal to 25 meter and R2 values is 40 meter. S1 value is 2.6 meter and S2 value is 1.9 meter. So as you all know that Q is equal to 2 pi T S1 minus S2 divided by ln of R2 by R1. So Q is equal to 1400 into 10 to the power of minus 3 divided by 60. So converted into meter cube per second. Is equal to 2 into pi into T into S1 value 2.6 minus 1.9 divided by ln of R2 value 40 divided by 25. So when you substitute these values, transmissivity T is equal to 0.00249. We want to find out the answer in meter square per day. So multiply this with 24 into 3600 to find a per day. So transmissivity T is equal to 215 meter square per day. This is the correct answer you have given. First write it down the given data which are available in the questions, then substitute the values in the formula. You can get the answer. For confined aquifer, this is the formula. Either they are requested to find the drawdown or transmissivity. Sometimes in rare cases they are requested to find the radius of influence. So thank you for watching. We can see the in next videos and the other left out problems in the previous year's question papers. Thank you. If you have any doubts, please leave the doubts in the comment section and do support us. Thank you.